All right. It's time for chapter 4. I'm pretty psyched about it. Jenny is pretty psyched about it. She's just laying on the garage floor right now. Maybe I'll get her in here in a little bit. But she's hanging out. She's ready to learn some math about polynomial functions and graphs. Fun fact, Officer Gregorio's favorite math term is polynomials. Should ask him about it one time. All righty, let's go. So we're going to identify polynomial functions and their degrees. We're going to graph them, use some transformations. Love using transformations. Identify our zeros, multiplicity. We're going to analyze. I mean, we're going to do so much with this. It's fantastic. Some of it's review. Some of it will be a little bit more challenging, a little newer. Let's go for it. As a recap, we've got our different names. Linear, quadratic, cubic, quartic, quintic. Beyond that, we just go nth degree, okay? So we're talking about the highest degree, and we like to write them in descending order in standard form, where it starts highest degree and works our way down, all right? So what shape is a quadratic? A quadratic is going to be something, let me get a marker here. It's going to be a U shape, or an N if it's negative. How about a cubic? A lot of times we're talking about it's like an S shape. It's like on its side, right? Or that would be a positive. This would be a negative cubic. Positive, negative. Positive, negative. All right, and how about a quartic? Well, quartic's going to be the W shape. Make sure we don't have any points in there, right? It's all nice and curved. That's a positive. And then when it's an M, that would be our negative quartic. Awesome. All right. Once again, standard form. Decreasing degree. Big deal, okay? It really helps to keep things organized. Always wonderful, a very formal definition here. A polynomial function. We have a sub n, x to the n, right, for that degree term. And then as we go down in decreasing order, that's what this is basically saying here, okay? So we're going down from the highest degree down to our constant a sub 0, okay? Awesome. Fantastic. So that might not be that wonderful for you, but let's talk about what's a polynomial, what's not a polynomial. So let's look at these 5 choices we have down here and which one is, which one isn't. Well, things you want to look for are integer exponents, okay? So exponents like 1, 2, 3, so on and so forth. Even 0, because that would be our constant, right? If we have 2x to the 0, that's really just 2, okay? So we want integer exponents. Well, a would be a polynomial. It's asking which one's not a polynomial. Here we have a fraction for an exponent, so that is not a polynomial. Here we have a negative for an exponent. Negative integers are no good, right? Positive integers or 0. And here would be an example where we have the exponent of 0 because there's no x there. X to the 0 is 1, so we're left with just a negative 5, a constant. Over here, it's in factored form, but if we distributed that 3s in, we would have 6s to the third power minus 3s. That is absolutely a polynomial, so I'm not going to circle that. I almost didn't follow directions. So only those two, the negative exponent, the fraction exponent, we're good. So this next example here has a couple parts. One, we're going to match the graph using the end behavior, and then we're going to do a little extra math down here about the leading term in number 3. So let's see here. I have a positive cubic function, and we know that looks like the S, and it's ending up to the right. So positive, it's going up and to the right. This would be part or letter C here. For number 2, it's a negative cubic, so that means it's ending going down and to the right, which would be B. That's this one right here. And then for the last one, obviously, we process of elimination, but I can see that I would have a degree of 2 and a degree of 2 if I were to FOIL this out and multiply all together, I get a degree of 4. That is a quartic function, and it's negative, so negative quartic. It's going to be that M shape pointing down, right, the upside down W. Boom. Wonderful. CBA. That's Cary Basketball Association when I was growing up shooting hoops in 4th grade. I could dunk. No, I never could dunk. I never will be able to, except on like the really short rim. All right. What is the leading term of number 3? So you could go through a terrible process of just foiling everything out, multiplying, distributing, and just wanting to cry. I'd rather not want to cry here. Math is a joyous equation. A joyous experience. Okay. Anyways, if I know right here, I'm going to have x squared and some other stuff. Over here, I'm also going to have x squared and some other stuff, right? If I foiled that out. So I'm going to have x to the 4th, and there's no coefficient here. There's no coefficient here. but there is the leading coefficient out front. So really, I'm taking my highest degree. I'm taking the negative 2 out in front, and then the x squared that's going to result here, the x squared that's going to result here, and I'm going to have negative 2x to the fourth. That is going to be my leading term. Why is this useful? Well, this can be helpful in deciding our end behaviors, right? Our end behaviors are decided by that leading term and whether it's positive or negative. So this one tells me it's a negative quartic, and I know how it's going to end on each end. Okay? So looking at our first parts of each that we would multiply out, each binomial or trinomial even, each one, that's going to tell us, I can put those together and get my leading term. All right, so we got to find the zeros of a polynomial and state its end behavior. This is nice. It's in factored form, ready to rock, ready to analyze. Oh, this is just so convenient here. So we've got, let's get our zeros. So I got a 0 at x equals negative 5 and x equals negative 1 with a multiplicity of 1. So it goes through the x-axis there. Whereas when it's at x equals 2, multiplicity of 2, so it will bounce or touch the x-axis, right? Instead of going through it, it's just going to bounce, all right? So that's all of our zeros and our multiplicity. Cool. Taken care of there. Discuss the general appearance of the graph of the function and or using the end behavior, the idea of end behavior. All right, so this is either going to be an M or a W, and because it's a positive, and how did I know it was an M or a W? I should backtrack. I have an X times an X times an X squared. If it were all FOILed out properly, I'd have X to the fourth. So I'm dealing with a leading term of X to the fourth. There are no numbers in front of these X's, and there's no coefficient out front, so it's just 1x to the fourth. It's going to be my first term if I were to multiply all this out. But I don't have to do that to just discuss the general appearance based on its end behavior. So it's going to look W in shape, and it's going to bounce off of when it's x equals 2, which would be this spot over here because it's the most positive. Okay? So if we were to actually graph it, that's what you'd see. You'd see something like, that should be a bounce. It's going through at negative 1. It's going through at negative 5. And this is at positive 2. Boom, there we go. America. Look at that. All right, so let's try this next example together here. We've got to figure out our x and y intercepts, state the leading coefficient. We got to state the constant term and graph it using the x and y intercepts. So let's start with the x and y intercepts. So x intercepts, well, I'm going to find that out from each one of my factors. The first factor doesn't have that usual like adding or subtracting a number, but this one you can think of as like plus 0. So 0, 0 would be one of them. The second one, negative 1, 0. And the third one, 5, 0. And how about my y-intercept? Well, my y-intercept, if I plugged in 0 for x, that's when it's crossing the y-axis, right? Anywhere along here, my x value is going to be 0. So if I plug 0 in, I'm going to get 0 out. And anytime you end up having 0, 0 for an x-intercept, it ends up being your y-intercept. But if I plugged in 0 here, 0 times anything, this is going to be 0. I don't even have to worry about anything else. Alrighty. Leading coefficient. Well, the first term, that's going to be negative x times x times x. That's going to be negative x cubed. So the leading coefficient is going to be negative 1. Okay, so that's for that one. But I think it's helpful to know that our first term is negative x cubed. That's going to help in the graphing. All right, the constant term. Well, since I have this negative x here, what ends up happening is my last term is actually just 5x. So no constant term. That's going to be my lowest degree term is 5x, and that's not constant. All right. So if this was another binomial out front, we would end up having a constant term, okay? And we'll see an example like that. So let's graph them. I'm gonna put some tick marks down. I've got 0, 0, negative 1, 0, and 5, 0. 1, 2, 3, 4. I did count that out right. Cool. And I know that this is going to be a negative cubic based on what I had said over here, right? That is a negative cubic function. It's going down and to the right based on my end behavior, what I know about that. And that will help me, whoa, that looks terrible. That'll help me graph this thing or have a general idea of how it's going to work its way through the points, especially when we start dealing with some bounces because we have the second degree, okay? Or a multiplicity of 2. All right, that was pretty exciting and fun. So let's we'll keep moving on. All right, so for this one, it's the same type of question as the last one that we just had. So what I'm going to do is I'm going to give you guys a sec to pause this, try it on your own, and then we'll go. I'll have the 4 parts here pop up for you. So hit pause on the video. Hit pause, pause, and then we'll go over it. All right, so here it is. We'll talk through it a little bit, but I figured this would save a little time if we just have it pop up. So I got my x-intercepts the same way, but this time I actually have to deal with the y-intercepts. I plugged in 0 for x, so you'd have negative 3 squared times 5 times negative 1 is negative 45. All right, fun fact. I'm jumping down to c real quick. That constant term is our y-intercept, right? So if we see the constant term, we know what our y-intercept is. If I know what my y-intercept is, it is my constant term, and you can see the math works out the same there. And lastly, I'm popping back up to b. If I multiplied all these x's out, x times x times x times x, I get x to the 4th. There's no number. There are no numbers in front of the x's. There's no number out in front there. So it's just 1 is my leading coefficient. So I got a positive quartic. There's my graph. It looks beautiful. It's wonderful. I think we're good. We're moving on. All righty, we're going to write some polynomial functions based on the graph shown. We use the smallest degree possible. And what we mean by that is, well, this is an odd degree. So we're going to use, in this case, a degree of 3, right? Rather than using some to the degree of 5, 7, so on and so forth. So we're going to use a degree of 3. So we want to leave it in factored form as well. Wonderful. Who wants to FOIL all that mess out? All right. So let's start with our zeros here. I've got one right here and here. So my zeros are at, or my x-intercept zeros are at negative 1 and positive 3. But this one is a multiplicity of 2. So if I put this into factored form, I'd have x plus 1 and x minus 3 squared. But there's a little bit more to it. There could be a leading coefficient out in front. We don't know. So I'm going to throw an a out in front there. It could be 1. It could be something totally different. We do know in this case it's going to be positive, right? It is going to be a positive cubic. So how do we figure out that a? Well, we could take any point on here, not from our factors. Let's take it from somewhere else. Like, how about our y-intercept of 9 up there, right? So I can throw in 9 for y, and I'm going to change colors doing this. I'd throw in 9 for y, leave a as is, and what's the x value going to be? It's going to be 0. So I'm just substituting a number in there, something that I know is on this graph, much like we would when we're trying to put something into slope-intercept form. I take a point that's on the line, and I take my slope, and I look for my y-intercept. So we're finding missing parts of the graph. It's just a different situation here. So I have 9 equals, and then I'd have a times 1 times the negative 3 squared is 9. So we might notice here that this is going to be 9. So I'm going to divide by 9 and divide by 9. And I'll get a equals 1. So my final answer here is going to be y equals x plus 1 times x minus 3 squared, since I'm able to leave it in factored form. My lead coefficient is 1. That's it. That one worked out very nicely. Sometimes they are different numbers, weird fractions. I don't know. The sky's the limit. Let's try another one over here. And what I think I might do for this one, I'll pause it. And we'll work it, and then I'll let you guys work it, and then I'll hit play, and we'll see the completed problem. All right, there we go. Here's our final answer. If you got it right, awesome, fantastic. You can ignore what I'm about. Actually, you know what? No, you should listen. It's going to be great stuff, regardless if you got it right. All righty, so I use my y-intercept once again. That's a point that I saw that was on there. If there's another point, sometimes we'll have something labeled on there that you can use, but if you can see where it crosses the y-intercept, easy money because you're going to use 0 for x, which is awesome. We end up getting negative 60 over here. Divide, we get 1 over 30 for our a value. It is a positive quartic. Honestly, I almost forgot this sign right here when I was doing this, and then I went to put -1/30, and I was like, wait a sec, this is a positive quartic function. Where's my mistake? And I went back and I saw that. Okay, so always verify that what you have there makes sense on the graph. Okay, all right, we got one more to do. All right, so I've got a graph here, and we actually have a point -1/6 that lies in the graph. Now we also have 0, 0, so you could use that, but let's go with this one just to show a different way of, or a different point and how it works. It works basically the same, but it's just a different point, but just for general practice. Okay, so once again, I'm going to pause this. I'm going to work it out and then hit play so you guys can see it. So please pause it yourselves and try and work the problem. All right, there we have it. Got ourselves wonderful little equation there. I did throw the X right here next to the 2. I think it's more aesthetically pleasing. What do you think there, Jenny? Do you think it's also more aesthetically pleasing? I think she wants to get off the couch here, but I don't know. You're having fun doing some math, right? Yeah? Okay. So that's River Dog Jenny on the gram. We use the point we use the point -1/6 instead of using our y-intercept. The math will still work out the same. Just depends on what we give you in a problem. So I think it was nice to try that. Yes, it was lovely. All righty. You guys have a fantastic day. America, freedom, rock and roll. Pre-Calc honors is just so darn fun. I'm so excited to be into a new chapter. I will see you guys in the next lesson. Woo!